Well, it's another hot, smoky day in Northern California. And in my last little clip, we discovered that we had a clearance issue again with the adapter, flywheel, so forth on the transporter. So we removed the adapter. We've taken it into the machine shop. We're waiting for them to remove a little material so we get back our magic number, and we'll remount that adapter, put the flywheel and clutch on, and hopefully get it back in this vehicle, because I'm really anxious to drive this thing and to cycle these batteries and to see once and for all what the reality is with this battery pack that sat in the Mojave Desert for 8 years. Preliminary inspection looks like it's perfect, but the true test is yet to come. But so now we're kind of stalled again, you know, not moving forward on our Doka. But fortunately, our adapter came in for the VW bus project that we've shared with you in the past, and it had been stalled waiting for some components. We now have everything to complete the job, and so we can get rolling, but we were waiting on the machine shop. So that is now behind us, and so we're going to shift gears from the Doka to the bus, and let me show you what we're going to be doing. First off, I'm going to comment on something I've commented on many times before. You'll see that we have most vehicles up on ramps, as is the case with the transporter right now. We just have the rear end up, and that was to get clearance for removing the engine, or the motor, I'm sorry. But when we're working on a vehicle, we either have them up on ramps or rollers. And in the case of this bus, we've got it on rollers because we have to move it around once in a while, just because this is our overflow here, and we got to jockey things around on occasion. So anyway, the point I wanted to make is the nice thing about the rollers, or the you know, which are nice for like the bus that already sits up higher, but the ramps is that they give a secure, stable way to elevate the vehicle just enough that we can get underneath easily. But more importantly, in the overall big picture of doing the conversion, it gives us the ability to you know, be at a comfortable height. So I can be sitting on my little stool here and be able to work in the engine bay here without bending over so much. And that's an important factor when working on a vehicle. A vehicle where you're underneath the hood, again, it's up on the ramps. It just means you don't have to bend over very far, and it really saves your back. And the older you get, the more important that'll be to you. So anyway, this is the back end of the bus. I'll bring in some light here in a moment, but we've got some wires and stuff just hanging because we're just kind of in the middle of things here, and everything will be routed and so forth, supported in a bit. We're going to have to move things in a moment here because I don't want these things in the way, such as these, which were existing wires, and we put that loom on them so that once they're held up, they'll be loomed except for where they're going to be supported. This ABS cover over the bell housing the customer put that in the strap in place, but we're going to remove that ABS cover, and we're going to mount or connect the adapter, just the adapter by itself, and I'll explain why. With the cover removed and the wiring moved out of the way, we're ready to temporarily mount. We'll just use 2 bolts, mount this thing in place so that we can take some measurements, and you'll see why in a moment. But while we're looking at the bell housing here, I want to remind you it's a good idea to always replace the throwout bearing. Not that you'll be using one very much in the future with a conversion, because you're not going to be sitting anytime with your engine spinning and the clutch in. You're just going to shift between gears, that's it. Throwout bearing will get used very little. But if you replace it now, you know, it'll last forever. You'll never have to think about it again. So before you mount the motor in place, this is a good time to do that. So let's go take a look at the adapter. So this is just the standard billet adapter, and we mount this piece of angle on there, and we're going to use it to mount our component board on this. So on the buses, the component board, and there's a few other vehicles we do this on, where we mount the component board to the adapter. And so drilled the holes in here, mounted this. We're going to mount the adapter in place, and then we're going to take some measurements. And on the bus, the clearance that we're wanting to check is the height. On the Beetles and Carmen Gias, we use a 12 by 24 inch component board. On the buses, it's typically 24 by 10. So we'll put this in. The buses, you know, different years have different idiosyncrasies you have to be conscious of. So we always double check, and that's what we'll do right now. Okay, the adapter, I don't have the nuts on the bolts. I just got the bolts and the holes in the bell housing there. But did our measurements, and thought my square was down there. Using a square as well as a tape measure, we took different measurements to make sure that we have the clearance. And in this vehicle we have something a little different. We have that wooden component board that we put that's going to be underneath the plexiglass, so that you can see the see some of the components through the plexiglass, and just kind of different. And so that could have possibly been a limiting factor, but I don't think it's going to be an issue. And we're actually going to go 12 inches on this, because to that board we've got about 11.5. So from the base of my mounting angle here to the board, I think that was 11.5 inches. And we normally have those pieces of aluminum that we mount to, they're cut 12 to 24. That's how we stock them. So instead of having a special piece cut in this instance, like we typically have to do on buses, this one we will not. So that'll be nice. And that mounting piece, this is 24 inches long. So end to end, that's 24. So it'll go across there up and just beyond that wooden board. The controller will stick out further than we have clearance to go dimensionally in this direction, but it only measures about 9 inches up, so we're not even going to be close. So on this side we do have the volt gauge hanging down, and normally that's where we put the controller, on that side. May have to do this one differently. I'll double check that measurement because I don't think we're going to have the clearance there. We'll see. But anyway, this is, the normal process is that the bus gets that attachment point, and so that component board will be bolted to this angle, and we'll do that next and test fit it, do some additional measuring with the board in place, and see what we think. I just gotta say, vice grips are one of the greatest inventions of all times. You can use them for so many things, and we definitely use them a lot. Well, here's the adapter. Just like I said, just got the bolts through the holes, nothing snugged up. But we have our component board and the inverter, controller, whatever you want to call it, in place, and we've got clearance, and you can see that the board just barely goes above the level of that wooden board, but actually a very nice fit, just the way that we had originally drawn it out. But sometimes you don't, you miss something, in the process, and but no, looking good so far. Let me show you what it looks like from above. So here's the view from above. We've got our wooden component board that we did early on, and then we have the aluminum component board behind there. So it's going to allow you to see from the side windows and stuff. You'll be able to see certain components down there, and if you remember our other buses, we'll have the throttle mounted on this board. We'll have the shunt and the main contactor. Now there will be some sideboards on here made out of ABS that attach at the edge here. There's an inch overlap, and then they will go out to the edges. And so it will cover that hole in the back there. And then on this side is where we typically put terminal strip. So all of the harness wiring that comes off of the wiring harness on the controller will go to that terminal strip, and from there to all the other locations. So things that go to the board up here, they will go from there. So it's modular in that we can disconnect the wiring that goes from this controller. It stays harnessed in place, and we can remove this whole board. Same way with this one as we did earlier. We showed you. We disconnected a few wires, and it allowed us to drop this whole board out of the way while we were dealing with the battery box. So anyway, on this side then, we usually put our coolant reservoir, and it'll go in the corner here, and we want it to be a little bit higher, so it'll go just above it'll go up pretty close to the wood here, but it'll be just above the chill plate, because our reservoir fill needs to be our highest point so we can bleed the air out of the system and have a high point fill. So, coming along, now that we have parts, we can really start making some progress. So next, what I'm going to do while this is in place is I'm going to mark where the throttle comes through, and it'll come through right about here. So we'll put a mark where that throttle pull is, and we'll put a pulley there, and that then affects the alignment of where we'll put our throttle. The other thing that we're going to do now, I'll remove the component board for this, just get it out of the way, but we're going to mount the adapter to the motor, and we'll put that assembly in here. And the reason for that, and we're not going to put the coupler or flywheel, clutch, any of that, so it's just going to be the motor mated to the adapter, and that's strictly going to be so that we can design the rear motor mount. So this has mounts on the side here. They're different on either side, but we're going to attach to the cross member, which I've got laying somewhere else. But anyway, it's the cross member that goes between those two mounting points I just showed you. We have to adapt between that stock cross member and the motor, and that will give us that rear motor attachment, which will help with supporting the weight of the motor and transaxle, as well as the torque. That's what's going to be our main torque control. Keep that motor from wanting to rotate. So anyway, we're looking good, and I'll pull this back out of the vehicle after I make that throttle mark and attach the adapter to the motor, and we'll go from there. This is the cross member just held in place, and if you put a square on here, you'll see that it clears, and that then allows us to put a piece on here that comes out to the end of the motor, because this is closer than the end of the motor. So let me see if I can do this without getting you too seasick. Should have put this on a tripod. Anyway, the motor's 14 inches long, and I don't know if it's showing on there, but 14 inches is beyond the cross member. So what we do is we have a plate that goes on this cross member. It comes out, cantilevers out, and will connect to the back of the motor. And there will be some shock mounts between that, so the motor is shock mounted. So that's what we're going to do next. I have to, like I said, mate the motor to the adapter. This time I will snug it into place so we can take our measurements and make sure everything fits properly. Boy, after working with the AC75, the AC50 looks so small. And it is quite a bit lighter. AC75 is, you notice it, you can't really manhandle it very much. This thing, he said you can pick it up if you want to. So let's put the adapter on it and put it in the vehicle. Okay. Just snug this on. And then, like I said, we'll just bolt it to the bell housing. And from there we can take our measurements. So you never want to force a bolt. You want to make sure you don't have things cross-thread, especially going into aluminum. We're just snugging these up. Because we'll pull it back out once we're finished with our measurements and all of that. So let's move over to the vehicle. Film and do this all at the same time. You can see these are a lot easier to do than, say, a Beetle or a Carmen Ghia, because it's pretty much a straight shot. And then using transmission jack allows you to tilt and get the right angle of an angle here. And I can rotate it a little bit if I need to. Here. There we go. Okay. Now I'm going to have to crawl underneath there and put the nuts on. So this is not room for me and everything else. I'll be back. Well, I've got the top bolts in. I'm just going to stick one bottom one in. It's really not necessary. Okay, so we've got the motor in. I've got it supported with the floor jack because the transmission jack just takes up too much of a footprint underneath there. So now let's put the cross member in place. And I think it goes this way. I might have to move the jack. Well, you don't really realize how much the lighting changes with the sun on a day like today. We've got smoke and clouds. So clouds go by, it gets kind of dark. I think one of my last segments was pretty dark. Anyway, it's a little bit brighter now. I got a light on inside the engine bay here. But we'll take a look at a couple different angles, but that's the motor in place. And let's see if we can get down here at this elevation. We've done this many times before. What I'm going to do is I'm going to take some measurements and see if we've got the specs for one. If this is the same as another one, then I'll just send those specs to the fab shop and they can crank this puppy out. So that's the cross member just temporarily in place, the motor temporarily in place, so that we can get our measurements. We need to know how far this is behind here. So this goes up, it's back a ways, and then there's a height difference here. So we'll measure all of that, and so I don't make any mistakes, that's all I'm going to do. I'm not going to be talking to you or filming it. I'm going to take my measurements.